end of year test 2020 for year ones. Question 4. One of the terms of this binomial expansion is 540x to the power of 4. Okay, looks like a binomial expansion question. We've got 6 as our power. Find the possible values of a. Well, we've got something to equate it to, and then we're going to find a term independent of x. So 4 marks for the first bit, 3 marks for the second bit. Part A, well, 3 plus ax to the power of 6. We know we've got a binomial coefficient, a 3 to the power of something, and then an ax to the power of something, something taken away from 6, don't we? And the sixth line of Pascal is 1, 6, 15, 20, 15, 6, 1. So if we did all the 7 terms of this expansion, we're going to get this. 3 to the power of 6, 3 to the power of 5, 3 to the power of 4, and so on. 3 cubed is 27, 9, 3, 1. So this is 81, this is 243, and this is 729. 6 take away 6 is nothing. Anything to the power of nothing is 1. And then what we're going to do, that term there is actually a plus term. So we're going to times 1 by ax, and we get ax. We're going to times ax by another ax, and we get a squared x squared. We're going to times a squared x squared by another one of these, and we get a cubed x cubed. We're going to times this by another one of them, and we get a4 x4, and I think you see the pattern, a5 x5 and a6 x6. And we know that this term is the same as 540x to the power of 4. So to answer this question now, we've got to do 15 times 9a4 is the same as our 540. Alright, I've ignored the x4s because they're the same in both parts. Look, this lot of x4 is the same as that lot of x4, so that lot must be the same as this lot. That's what I've written down there. So a4 is equal to 540 divided by, well, 15 nines, I think, is 135. And 540 divided by 135 is 4. So a is equal to the 4th root of 4, and that's equal to the square root of 2, and it's plus or minus. Alright? Plus or minus the square root of 2, so we don't need to write that down. The question says, find the possible values of a. It doesn't say find the exact answers for a, but that's implied. Yeah. If you write 1.414 or minus 1.414 in this question, you don't get that final mark. It needs the possible values of a really exactly. And part B, hence find the term independent of x in the expansion of. Okay, so when we do 1 over 81 plus 1 over x to the power of 6, and we times that by 729 plus 6 times 243 ax plus 15 lots of 81a squared x squared and we keep on adding those terms until we get to the last one, which is just 1 times 1, which is 1a6x6. How can we get out of this multiplication of these two terms times each one of them an answer which doesn't have any x's left? Well, when I multiply that one by this one, I get 729 divided by 81 is equal to 9. Then, multiplying the 81th by all of these, I get something, 6 times 243 a divided by 81 x's plus so on. This is not independent of x, and when I multiply 1 over 81 by any other term in there, I'm going to get an x squared times something plus an x cubed times something else. None of these other terms, or that one, will be independent of x. When I multiply 1 over x by 729, I get 729 over x to the power of 6 plus 6 times 243 a times the x divided by x to the 6 is divided x to the 5 plus something over x to the 4 plus and so on until I get to this term, where I get a to the 6 times x to the 6 divided by x to the 6, which means it's independent of x. So I don't want any of them. I want 9 plus the square root of 2 to the power of 6, and that's equal to 9 plus 8, and that's equal to 17. Alright, there's our processes. Where's our marks? Well, this is 1 mark. Getting this equation with an a to the power of 4 is our second mark. Getting a is equal to the 4th root of 4 is our third mark. And our final mark, final accuracy mark. So this is an M mark. This is another method mark. This is an accuracy mark. And so is that one. Where's our 3 marks for this one? Well, we need to have at least one of those. That's our first method mark. Then there's, I think that's another method mark, and this is our final answer.